Hello, and welcome to another exciting Max MSP tutorial. In this video, we're going to do frame differencing, which is like computer vision in motion, to MIDI, so we can make music when we do this. It's going to be pretty exciting, and then there's a couple different concepts we're going to cover with this one, so please stick around and let's just jump right into it. Alright, so the very first thing we need to do is create the window for us to see ourselves. So we're going to create a jit.world at floating 1. We're going to say at FSAA1 and at FS menu bar 0. These are just starting parameters that I like to always have in my jit.world object. The floating keeps the window floating. FSAA1 stands for full screen anti-aliasing, so it's nice quality full screen, and FS menu bar hides the menu bar when we're in full screen. And now that we have our window, we can attach a toggle into the object and turn it on, just like I have done, so that the window starts rendering. And then we need to create a video plane with the parameter at transform reset 2, so it stretches to the edge of our window, and then we can send some video data to it for us to see what's going on. Now I'm going to use the jit.grab object so that we can use the webcam, and I'm going to say at unique 1. This filters out duplicate frames, which is a very important step for doing this frame differencing technique. This has to be turned on in order for this to work as efficiently as possible. And once you patch that into your JitGL video plane object, you can just create an open message and lock your patch and click it, turn it on, and then you should see yourself in our jit.world window. Now I'm going to throw another object in here called jit.dimMap, which flips the video plane, so that way when I raise my right hand, it's going to be on the right side of the window, and it mirrors what I'm doing, and it feels much more natural this way. Okay, and now that you can see me, I'm going to explain to you what frame differencing is. It's a fun concept where you take two consecutive video frames, so from one frame to the next of a video, and you subtract them, and you get the difference between the two frames, which we can then calculate into a value that equals motion. So the more difference there is between the two frames, the more motion there's going to be. And it's a very awesome technique to use in Max MSP because you can make a lot of things interactive just based on frame differencing. And it's very simple to do. So let's just jump right into how to do that. First things first, we need to take our matrix, our beautiful full color 4-plane matrix, and convert it down to a 1-plane matrix. So we're going to use the object jit.rgb to Luma, and if you patch your patch cords in properly, jit.dimmap to the RGB to Luma and RGB to Luma to JitGL video plane, you'll see we are now grayscale, and it's because we have just one plane matrix. And this is necessary for doing the calculations properly, so we get the correct value. Once you have done that, once we've converted down to grayscale, we're going to use a trigger object. A trigger object does actions sequentially. So if we say T, which stands for trigger, and then LL, and the L stands for list, which technically a jitter matrix is, so technically this webcam data is a list. We can do TLL and then do jit.absdiff to take the absolute difference between frames, and all we got to do is crisscross applesauce our patch cords, and then if you patch that into the video plane, you'll see we get this beautiful outline of the difference between the two frames. So if I stand completely still, I'll fade out of view. And the reason for that is because there's no difference between the frames. And this is where this at unique 1 attribute for the jit.grab comes into play. If that wasn't turned on, it would pass duplicate frames and we'd subtract the same thing from the same thing. And this beautiful, smooth video effect you see in this window would be very glitchy and choppy, and it would not look right, and our values would not come out right. This is frame differencing right here. This is the technique, but the extrapolation of the data is what we're really looking for. And to do that, all you got to do is use this beautiful little object called jit.3m, which reports the minimum, the mean, and the maximum values for a jitter matrix. So if we patch our jit.absdiff into that, and then we press F to create a float number box, and we take our middle outlet, which is the mean, and we patch that into this float number box, we see now there are some values, and keep your eye on this value. As I rapidly move my hand back and forth, you see it jumps up. And that's because this is calculating a mean of all the pixels you see in the window and adding them up and doing, mean math. And it's giving us a value that is representative of the overall average of pixels in the window, which in our case directly attributes to motion. The less movement there is, the smaller that number will be, and the more movement there is, the higher that number will be. So we can now map motion into anything with Max MSP, but I'm going to map it into a MIDI playback code because one, it's simple, and two, MIDI is also a very valuable thing to understand in Max MSP. If you know how to work with MIDI, there's a lot you can do with Max MSP. So I thought motion to MIDI would be a good dual topic to cover. So I'm just going to move these objects around a little bit, create some room for ourselves, and we are going to then jump right into doing MIDI stuff. So first thing to do, if you're pretty new to Max, we have this beautiful object called a K-slider, which is this wonderful piano looking object, and basically you feed it a numerical MIDI number and it represents what the note is on a piano. So it's really helpful in terms of visualizing MIDI notes as you would play them on a musical instrument. And if I take the outlet, the left outlet, which is the pitch of the value, and I patch that into the right inlet of our message box, we can see that our lowest MIDI value on this K slider is 36. And if I click the highest note, we'll see that that value is 83. So if we want the range of this entire K slider, in order to have that be our MIDI sequencer, we just need to take the high value and subtract the low value. So if we do 83 minus 36, and we, oops, this should have been a message. 83 minus 36, and we patch that into the right inlet of another message, we can see that the number is 47. So I'm going to create this object called drunk, which outputs a random number, but it does it in a special way where you define a range and then you define a step number. So the first random number that comes out of drunk can be any random number in your range, but then the next random number is going to be somewhere within that step range above or below. So I did 47 for a range of notes, and then I did a step of 8. So if it was, 57, only this, all the way up until 8 or below 8 can be our next number. So it kind of creates like a stepwise pattern, which is a little bit different than how random would do it. Random would just be jumping around all the time. This is just going to create something that's a little bit more melodic. Yeah, and to get a new number out of this drunk, we're going to have a threshold for our motion. So if our motion is above or equal to, say, 13, then we are going to convert it into a bang using the cell object, and we're going to send that bang to our drunk object. And if we patch that into the K slider and I start moving around, you'll see we are getting some numbers. Now it's not in the K slider range. We actually need to do plus 36 after our drunk object, so that way it starts at 36 as a minimum and goes up some 47 values to our max range. And now we'll start to see those values being represented on a K slider. And we can see it. We see it as playing those notes, but we're not hearing anything. And that's because we need to tell it to output as an actual sound. And to do that, we can use the object make note, and we just got to put some values into it. You see that the arguments are velocity and duration in channel. So the first number is our velocity. 120 is a pretty high velocity. It's like hitting it almost as hard as you possibly can. And duration is in milliseconds. So 500 milliseconds, that's half a second that the note is going to ring out for. And then all we got to do is patch our K slider into our make note object. And then we have one more object called note out, which actually will take this format of the make note object and how it formats it as a MIDI event, and we'll tell it to play that MIDI note. We just got to patch the left outlet into the left inlet for pitch and the right one to the middle one for velocity. And now you see, as soon as I do that, our motion is playing MIDI notes, which we can hear. And it's pretty beautiful. And that's actually like the basic of this. Like, you are already doing motion to MIDI notes. The only thing really I want to recommend from this point in the tutorial is how to smooth the data a little bit so it just sounds somewhat better and more natural and responsive. So real quick, I'm going to create a message called close for jit.grab and close the webcam data for just a second, just so I'm not triggering MIDI notes while I'm trying to talk and explain things. And we're just going to throw a scale object into the mix. And what we're going to do is scale our motion value to be the parameters of our make note object. So that way it's responsive to the motion. The softer I'm moving, the softer the velocity of the notes are going to be. And actually, instead of 60, let's just do 0. And this value is our motion. If I turn the webcam back on and start moving, you'll see that like this number range that we're getting is all over the place. It's not like any one specific value. It's like going between 0 and like 38. So it's kind of like an arbitrary value range. So you kind of have to like just test and check like I was just doing to figure out what you want to throw into your scale object. We're just going to say 0 to 40 for the motion range, and we're going to scale it to be between 0 and 120 for our velocity range. And then we're just going to copy that object so we have the same input, but we're going to change it to 250 and 1000 for our duration range. And again, we're just going to take the motion value from that, and we're going to see how that turned out. And you can see it's a little bit more naturally responsive. The softer my movements are, the softer the sound is, but if I move a lot, it's playing it pretty hard and pretty long. So yeah, it's much more naturally intuitive this way. Last thing I think I want to throw in here is a speed limit set to 65, because that is a very small number. And just patch that in between our cell and our drunk so that it's not constantly triggering notes. And let's just actually, just for funsies, throw a scale object in there and say 65 at our minimum and 500 at our maximum, and patch our motion value in there. So now the higher the movement is, the less notes are going to come through. That's pretty beautiful. This is I would have a lot of fun with this. Yeah, we can even just throw the regular webcam back into our video playing. So it's just the normal. Ooh, I want to do it with at least the dim map so it's mirrored properly. There we go. I could play with this for a while, just making beautiful music. And this is a very simple patch. We just did a very basic thing and we're already done. That was like so easy. And this is, you know, because it's so basic, you can expand upon this pretty easily. Like if you know a better way of generating MIDI note values, then there you go. You can do that instead of our drunk object. This is really just a basic thing to expand upon. But I hope it was informative. I hope you learned a cool technique. Maybe you didn't know about frame differencing. Maybe you didn't really know about how MIDI worked. And now you do, and that's awesome, and I'm very glad that we have shared this moment of teaching together. If there are any questions or comments, maybe you want further clarification, please leave those in the comment section down below. And I will be happy to explain anything more in depth. Please like and subscribe if you actually enjoyed this tutorial video. It lets me know that I'm doing a good job, and I really appreciate that kind of feedback. And the last note I want to make is I have a Patreon now. There's a link for that in the description down below as well. If you subscribe to my student tier on Patreon, you can get this patch highly annotated, full explanations from the video, so you don't even need to watch these videos if you subscribe. and it's going to be all there for you to download and mess around with on your own. And if you buy one of the higher tier patches, I'm going to offer more stuff too. There is going to be some fun artsy patches that I have just made that you can play with and use, and it's really cool stuff, especially if you like interactive media. And then there's the master student package, where I will be making breakdown tutorials on how I make some of my personal projects, and they will be very in-depth and very full of high-level advanced knowledge. So please consider subscribing to my Patreon if you like, and just know that that helps support me and me making these videos, and I really appreciate everything that you guys would do for me, as I am trying to do for you. We're all in this together. So on that note, I'm gonna head out of here, and I will see you in the next tutorial video. Thank you.